All right, to find the period, we count the first 5 points. So 1, 2, 3, 4, 5. Your period is 2 pi. To figure out the amplitude, we need to look at the maximum and minimum values. So your smallest value is -1. That is a minimum value. Your largest value is 5. That is a maximum value. That means your midline is at 2. So the distance between these two values is 3. That's your amplitude. We already said our midline is at 2. And the way we tell if it's a sine or cosine function is what it starts on. In this case, it starts on the midline instead of one of the amplitudes, which would be the max or the min. This is going to be a sine equation. Sine starts on the midline. So it starts on a midline value. All right, so your equation is going to be y equals your amplitude times sine. Your period isn't changed, it's the normal period, so it'll be 1 in front of the x plus your midline. All right, period, count your first 5 points starting on the y-axis. So 1, 2, 3, 4, 5. Your period is pi. To find your amplitude, we want to look at that midline first. So here's our midline. And our amplitude is a value of 2. Our midline, I just drew that, was at 1. This is a sine equation because it starts on the midline. That's how we know. It starts on the midline. All right, our equation should be the amplitude times sine. In this case, it'll be times 2x because we want to always divide 2 pi by our period. Pi's cancel out, so we need to put a 2, that's your b value, in front of the x, plus your midline. Now this is only partially right because we need a negative in front since we are starting with a lower amplitude after the y-axis instead of up. Sine usually goes up first. Okay, counting our first 5 points. Starting on the y-axis, 1, 2, 3, 4, 5. Okay, so that means our period is 2 pi. Again, with our amplitude, we want to make sure we draw that midline first. So we have an amplitude of 4. You can count on any of these. Drew the midline at 2. This is a cosine equation because it starts on either a minimum or a maximum, or another way to say that is on the amplitude value. We know it's not sine because it does not start on a midline value. So your equation should be amplitude cosine. There's no change in the period. If you wanted to use the method I just did in the last problem, that would be 2 pi over 2 pi. That all cancels, so it's 1. That's your b value. Plus the midline. And again, we need a negative in front because we're starting at a minimum, a negative value or lower than the midline first. Okay, so we need to compare h and g. So h of 0 is going to be -2. And g of, oops, let me fix my notation there. H of 0 is going to be -2. And g of 0 is going to be 1. So g of 0 is greater. That means this one's false. Okay, f of pi, we can just read that from the table. F of pi is 2. H of pi, let's see, pi is right here, so that is 2. That's also false because they are equal to each other. F of 0, again, we can go read that from the table. F of 0 is 2. H of 2 pi is also 2. All of 3 of those are false. All right, so the Ferris wheel should be very common by now. We know the 25 represents the radius of the Ferris wheel. The 40 represents the center height. And then the 3 is the frequency or the speed that the Ferris wheel is moving at. So the 40 represents the center height. The diameter of the Ferris wheel is going to be 25. The radius times 2. 25 plus 25 is 50 feet. And the height at the top is going to be 25 plus 40. So it'll be 65 feet. All right, so the diameter is 60. The radius is 30. The maximum height is 70. Then your center height is going to be 70 minus 30. So your center height is going to be 40. Another way to figure that out is if you're 10 feet above the ground, 10 feet plus the radius, which was 30, equals 40. After pi seconds will help us figure out the period, so we'll do 2 pi over pi. So your period, your pi is your period, your frequency is going to be 2. So we'll do radius times sine of the frequency t plus the center. This is the equation that we follow for all of our Ferris wheels. So in this case, that'll be 30 sine 2t plus 40. So that's letter D. All right, so 13, we need to use your unit circle. We're looking at the y value since we want sine. So sine of 60 at 60 degrees, the y value is root 3 over 2. At 4 pi over 3, the y value is root 3 over 2. At 330 degrees, the sine value is 1/2. At sine pi over 4, the y value is radical 2 over 2. At sine 300, the y value is 1/2. No, sorry, root 3 over 2. And that's actually negative, so my bad, I need to go back and make that a -1. And a negative root 3 over 2. Sine of -30 is going to be the same as sine of 330. So that'll be -1/2. Sine of 2 pi over 3 is going to be equal to root 3 over 2. And sine 45 is going to be root 2 over 2. So now all we need to do is match. So let's see. 3 over 2 goes with C. Negative root 3 over 2 goes with A. -1/2 goes with B, and root 2 over 2 goes with D. All right, for the next problem, we are going to want to draw our x and y axis with 0, 0 here, and it says go 12 in the negative direction and 5 up from the point. So here's our triangle and our angle. This is the opposite, this is the adjacent, and here's the hypotenuse. Our goal is to write a ratio for sine. We know sine is our opposite over our hypotenuse ratio. We have our opposite, we know that is 5, but we need to do some work to figure out that hypotenuse. So you can use Pythagorean theorem. 5 squared plus 12 squared is equal to c squared. So your c value is going to be 13 after you take the square root. So your ratio is going to be 5 over 13 for number 14. Okay, so for number 15, you just really need to understand your quadrants for sine, cosine, and tangent, and when it's positive and when it's negative. So let's start out with sine. Sine is our y value. Y is positive in first quadrant and second quadrant, negative in third and fourth quadrant. Cosine is your x value. X is our positive in first quadrant and fourth quadrant, negative in second and third. And then tangent is going to be your x over your y, or excuse me, your y over your x. So we just need to divide. So we'll do first quadrant, positive divided by a positive is a positive. Second quadrant, positive divided by a negative is a negative. Third quadrant, negative divided by a negative is a positive. And lastly, fourth quadrant, negative divided by a positive is a negative. And if you forgot what your quadrants look like, here's quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. So for cosine, we have a negative value in quadrant 2 and quadrant 3. Tangent, there's a negative value in quadrant 2 and quadrant 4. And sine is a negative value in quadrant 3 and quadrant 4. For number 16, we want when sine is negative, so that's possibly in quadrant 3 or quadrant 4. But we also want when cosine is positive, that's saying it's greater than 0. So cosine is positive in quadrant 1 or quadrant 4. The overlap here is quadrant 4, so we need to draw our triangle in quadrant 4. So our ratio is -4/5. So that means when we draw our triangle from our angle, our opposite side for sine, remember sine is opposite over hypotenuse, is going to be 4 over the hypotenuse of 5. We want to write our tangent ratio. We know our tangent ratio is supposed to be opposite over adjacent. We already have our opposite side. We know that is 4, and it should be a -4 since we're going down. That's the y value. We just need our adjacent side. Again, this is a Pythagorean theorem problem, so we're going to do Pythagorean theorem to figure that out. We'll have 4 squared plus unknown squared is equal to 5 squared. So that'll be 16 plus x squared is equal to 25. And then we'll have to subtract 16 from both sides. X will equal 9. X squared will equal 9, so x will equal 3 when you take the square root. So put that over 3, and then you're done. Again, fourth quadrant, tangent should be a negative value. It's the exact same type of thing for number 17. We want to have a negative cosine. That means we're going to be drawing in quadrant 2 or quadrant 3. We know we're going to be drawing in quadrant 2 because we need to stay between 90 degrees, which is at the top, and 180, which is at the left. So we're going to draw a triangle right here. We'll put -√7 as the adjacent sign, and 4 is the hypotenuse, since cosine is adjacent over hypotenuse, excuse me. We want to draw the sine value or write the sine value, so we know sine is opposite over hypotenuse. We have the hypotenuse, which is 4. We just need to figure out the opposite side, which we can do doing the Pythagorean theorem again. So we'll have √7 squared plus unknown squared is equal to 4 squared. The square and the square root cancel each other out. They're inverse operations. So x is going to equal 3 once we take the square root. So we put a 3 there, and then you're done. Okay. So if 2 is our b value, we can figure out the period again by doing 2 pi over the b value. Again, that b value is called the frequency. So 2 pi over 2, that means your period is pi. If you can figure this out with degrees, you would have gotten 180. Then you would need to convert that 180 into radians. We know 180 is the same as pi radians. Your amplitude in this problem is 3. Please make sure to always make your amplitude value positive. The negative just tells you you're going to reflect. It's not part of the amplitude. Our maximum value can be found by adding the amplitude and the midline, so that would be 7. Your minimum value would be the other direction. So instead of starting at 4 and going up 3, we're going to start at 4 and go down 3. That means our minimum value is at 1. Your y-intercept for cosine is either going to be a minimum or a maximum value. We know it's a minimum value in this case because of the negative in front. So your y-intercept should be 0, 1. That's from the minimum value again. And the midline is 4. For g of x, we're going to do the first 5 points. So 1, 2, 3, 4, and then 5 to give us the period. And then you're just looking at your values. The biggest value you see is 6. That's your maximum. The smallest value you see is -4. That's your minimum. That means the one smack dab in between is your midline value. So your midline on this problem is going to be 1. We can figure out our y-intercept, or excuse me, we can figure out our amplitude by seeing how far in between the midline is from your maximum or from your minimum. So from 1 to 6, that's 5 spaces. Or from 1 to -4, that's 5 spaces. So your amplitude is 5. Continuing on with the maximum value, we've already discussed the maximum value is 6. The minimum value is -4. Your y-intercept, that's wherever x is equal to 0, so in this case 0, 6. Okay, and then you just need to look at your table to answer these as true or false. So for A, g of x has a greater maximum value. G of x clearly does not have a greater maximum value. F of x is 7 for its maximum. G of x is 6. This is a false statement. Letter B, g of x has a greater minimum value. So looking at the minimum value, g of x is at -4 and f of x is at 1. That's not true. G of x is a smaller period. Nope, that's false as well. G of x is a larger period. 2 pi is larger than pi. Both functions have the same midline. Nope, still not true. One's at 4, the other's at 1. G of x has a lower y-intercept. Nope, false again. G of x's y-intercept is at 6, f of x is at 1. That's clearly greater. All right, that's it. Hope you guys do well tomorrow. Good luck studying.